In this video, I want to review three essential concepts to understand vector lines. First, let's look at scalar multiplication. So over here I have this vector v, and you can see that v has components 2, 1. So 1v is just the vector v. And now let's look at 2v. 2v, we can think of 2v in two different ways. We can think of 2v using the definition. So that would be 2 times the x component here, which is 2, and 2 times the y component there, which is 1. So we see that 2v is the vector for 2. Another way to think of 2v is geometrically. We can think of 2v as the vector with the same direction as v, but with twice the magnitude. So 2v is that vector. You can see here that this is v, and that is 2 times v, or twice v. Now how about negative 1v? Using the definition, this is negative 1 times 2, negative 1 times 1. And as we know, this is negative 2, negative 1. Thinking of this geometrically, we can think of this as v in the opposite direction. So that vector there. Negative 1v. Lastly, let's look at 1/2 v. Again, using the definition, this is 1/2 times 2, 1/2 times 1. So we see that 1/2 v is 1/2 of 2, which is 1, and 1/2 of 1, which is 1/2. Thinking of 1/2 v geometrically, this is the vector with the same direction as v, but only half as long, with only half the magnitude. So that's this vector there. We can see this is v, and this little thing there, half the magnitude, is 1/2 v. Now let's move on to vector addition. So I have a vector v here. V, as we've already discussed, has components 2, 1, and a vector w there. W, you can see, has components negative 1, 1. So v plus w, using the definition, the definition says to add the components. So we have 2 plus negative 1, or 2 minus 1, and 1 plus 1. which is 1, 2. We can also think of v plus w geometrically. So v plus w, what we do geometrically is we move the initial point of w to the terminal point of v and then redraw w. So w there. Now we have w there. And v plus w is this green vector here. And you can see that it points to the point over 1 up 2. Similarly, let's look at w plus v. Now, doing the math, using the definition, you would see that we could come out with the same answer. This is because addition can be done in any order. It's commutative. Now, what would this mean geometrically? Geometrically, w plus v, we move the terminal point, or we move the initial point of v to the terminal point of w. And then we redraw v here. Notice that v goes over 2 and up 1. So going over 2 and up 1, we get that vector there. Now in green, I'll draw w plus v. That's this green vector. And notice that in fact, we do get the same point 1, 2. We do point or draw the same point 1, 2. Now let's move on to vector subtraction. Now, vector subtraction is really just vector addition. Vector subtraction, the vector subtraction v minus w is v plus negative w. We can figure out vector subtraction using the definition of vector addition. So v plus negative w, I guess technically using the definition of vector addition and scalar multiplication. So let's see, v we said was 2, 1, and now we want to do plus negative 1 times w, which is negative 1, 1. So we have 2, 1 plus 1, negative 1. Remember, vector addition, we add the components. So we have 2 plus 1, 1 minus 1, which gives us 3, 0. So here we see that vector, that v minus w is the vector 3, 0. Now, thinking of this again geometrically, right? First, let's find negative w. So negative w is that vector there, brother. is that vector there. That's better. And v plus negative w, remember we've moved negative w so that the initial point of negative w is at the terminal point of v. That gives us that. And then the vector sum, v plus negative w, as you can see, points to the point 3, 0. With these concepts in hand, we can now move on to vector lines.